Have you ever looked up at the night sky and felt a strange sense of wonder? As stars twinkle above like distant lanterns suspended in an infinite black sea, a single question starts to echo deep inside us all. Asterisk, are we alone out there? Asterisk, it's a thought that has gripped the human mind for generations, sparking imagination, stories, science fiction, and, eventually, groundbreaking space missions. We've always been curious, always searching, always trying to understand what lies beyond our tiny world. And now, thanks to one of the most powerful space observatories ever built, we might be closer to an answer than ever before. Enter the James Webb Space Telescope, also known as JWST, a marvel of engineering, a machine so powerful it can see back in time. Launched with the goal of exploring the earliest galaxies and peering into distant solar systems, the JWST is now pointing its massive eye towards something much closer, yet equally mysterious: the possibility of life beyond Earth. With its incredible sensitivity and precision, JWST has become humanity's most capable tool for studying the cosmos, especially exoplanets, those strange and distant worlds orbiting stars far from our own. One of its most promising targets so far is a fascinating exoplanet called K2-18b. Tucked away in the constellation Leo, just 120 trillion kilometers from us, or about 120 light-years, this planet has captured the imagination of astronomers everywhere. Why? Because K2-18b isn't just another rock floating in space. It's a world that might actually support life. And that possibility, no matter how small, is enough to shake the foundations of everything we know about our place in the universe. When the JWST began observing K2-18b, the data it returned caused a ripple of excitement in the scientific community. This wasn't just about finding another planet in the so-called Goldilocks zone. It was about detecting something far more significant: the presence of specific molecules in the planet's atmosphere, molecules that, on Earth, are closely linked to life itself. This discovery was more than surprising. It was a potential milestone in the search for extraterrestrial life. Could K2-18b be the first real sign that we're not alone? Let's take a closer look at this fascinating world. First off, K2-18b is what scientists call a super-Earth, which means it's larger than our planet but smaller than Neptune. It belongs to a unique category known as sub-Neptunes, a type of planet that doesn't exist in our own solar system. That alone makes it mysterious. With no local examples to compare it to, scientists must rely entirely on remote data and modeling to understand what these planets are like. It's like trying to describe an animal you've never seen before, based only on its shadow. The size of K2-18b presents a unique puzzle. At about 2.6 times Earth's radius and roughly 8.6 times its mass, it's significantly larger than our home planet. Yet, it's not large enough to be classified as a gas giant. This middle ground raises many questions. Does it have a solid surface? Is its atmosphere thick with gases? Could it support oceans or even rainfall? These are not easy questions to answer, especially when we're talking about a planet over 100 light-years away. But JWST's observations have brought us closer to understanding it than ever before. Perhaps most importantly, K2-18b resides in what scientists call the habitable zone of its parent star, K2-18. This zone, sometimes called the Goldilocks zone, is the sweet spot where a planet is neither too hot nor too cold for liquid water to exist. And as far as we know, water is the key to life. It's one of the essential ingredients that helped life emerge on Earth. So when astronomers spot a planet in this zone, their excitement is justified. It's like finding a hidden oasis in a vast desert. You just have to explore it. But this isn't just any star system. K2-18, the host star, is a red dwarf, a type of star that is much smaller and cooler than our Sun. These stars are the most common in the galaxy and tend to have very long lifespans, sometimes lasting trillions of years. Because red dwarfs emit less light, their habitable zones are much closer in than what we see in our own solar system. K2-18b, for example, orbits its star at just 0.18 astronomical units, much closer than Mercury is to our Sun. Under normal circumstances, a planet this close would be scorched. But because its star is so dim, the planet can stay at a temperature that might support liquid water. And that's where things get really interesting. In 2019, using older telescopes like Hubble, scientists first detected water vapor in the atmosphere of K2-18b. That alone was an incredible discovery. But JWST has now confirmed it with much more clarity. The presence of water vapor in the atmosphere of a planet this far away is absolutely mind-blowing. Think about that. Water, the same molecule that covers over 70% of Earth's surface, floating in the skies of a distant exoplanet. It's hard not to feel a chill down your spine when you hear something like that. But the surprises didn't stop there. JWST went a step further and found signs of something even more intriguing: dimethyl sulfide, or DMS. On Earth, this molecule is produced primarily by living organisms, especially marine plankton. In fact, nearly all the DMS found in Earth's atmosphere comes from biological activity. If that same molecule is truly present in the atmosphere of K2-18b, it raises an enormous question. Could something be living there? While scientists remain cautious and insist more data is needed, this finding represents a massive step forward. It's not proof of life, but it's a signpost that points us in that direction. Understanding the atmosphere of K2-18b isn't just about finding out what's in it, it's about figuring out what kind of planet this really is. Some models suggest it may have a thick, hydrogen-rich atmosphere with a liquid ocean beneath. Others propose a water world scenario with global oceans covering the entire planet. There are even ideas that the atmosphere may support cloud layers, much like what we see on gas giants. Each of these possibilities comes with its own implications for habitability. But no matter which turns out to be true, one thing is clear: this is not an ordinary planet. Even the gravitational forces at play on K2-18b are extraordinary. Because it's so much more massive than Earth, gravity on its surface could be up to twice as strong. That means if you were to stand on it, assuming it has a solid surface, you'd feel incredibly heavy and even basic movement would be difficult. That's if you could even survive the atmospheric pressure and composition. But again, this doesn't rule out life. It just means that if life exists there, it would be very different from what we're used to. And here's where things get philosophical. If K2-18b does harbor life, even in microbial form, then it changes everything. It would mean that life is not a fluke, not a one-time event that happened only on Earth. It would mean the universe is biologically fertile, that life could arise in many different forms, in many different places, under many different conditions. And that opens the door to countless other possibilities, some thrilling, some terrifying, all profoundly important. As we continue to analyze the data from JWST, scientists are already planning follow-up observations. The goal is to gather more evidence, more clues, more pieces of this interstellar puzzle. Every molecule, every spectral line, every blip in the data could bring us closer to the answer humanity has been chasing for thousands of years. And even if K2-18b turns out to be lifeless, the very fact that we're able to study it in such detail is a testament to how far we've come. From ancient skywatchers mapping constellations with the naked eye to modern telescopes unraveling the secrets of alien worlds, the journey of discovery continues. And with the James Webb Space Telescope leading the way, the next revelation could be just around the cosmic corner. Have you ever looked up at the night sky and felt like something was watching back? We stare into the darkness, surrounded by stars that stretch beyond our comprehension. And in those quiet moments, one question always seems to echo in our minds: are we alone? It's a question that has haunted humanity for centuries. A mystery that pulls at our deepest sense of curiosity. Now, thanks to the most advanced space telescope ever created, the James Webb Space Telescope, we might finally be inching closer to an answer. And it all begins with a strange, distant world called K2-18b. Imagine a telescope so powerful that it can look beyond planets, through their atmospheres, and detect invisible gases floating in the alien air. That's the James Webb Space Telescope, an engineering marvel launched into orbit not just to take pretty pictures of stars and galaxies, but to help us answer the greatest question of all: is there life beyond Earth? It works like a giant magnifying glass floating in space, capturing light from the farthest reaches of the universe and decoding the secrets hidden in its glow. It sees things that human eyes never could. And what it's recently discovered might change everything. Among its most thrilling missions so far, JWST turned its gaze toward a planet orbiting a faint red star about 120 trillion kilometers away. That planet is K2-18b. At first glance, it might seem like just another exoplanet among thousands already discovered. But this one is different. The initial data shocked scientists. K2-18b isn't just interesting, it's potentially historic. Why? Because it may be the first planet outside our solar system where we've detected molecules tied to life. Real life. The kind that could exist right now, swimming in alien oceans, hidden under clouds of gas. Let's take a deeper look. K2-18b is located about 120 light-years from Earth in the constellation Leo. It's classified as a super-Earth, or sub-Neptune, a type of planet that doesn't exist in our own solar system. That's already intriguing. It's bigger than Earth but smaller than Neptune, and because of its size, it falls into a gray area that scientists are still struggling to fully understand. It doesn't fit into the neat boxes we've built based on our own backyard. That alone makes it a mystery worth investigating. Back home, Earth and Mars are rocky planets with atmospheres that we understand pretty well. Jupiter and Saturn, on the other hand, are massive gas giants that operate under very different rules. K2-18b doesn't follow either of these models. It floats in between as something new. That makes it both harder to study and more exciting, because it might offer environments we've never seen before, ones that could support alien biology that doesn't follow Earth's rulebook. But here's where things get really interesting. K2-18b orbits in what scientists call the habitable zone of its star, a red dwarf named K2-18. The habitable zone is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. And water, as you know, is the foundation of life as we know it. But red dwarfs are different from our sun. They're cooler, dimmer, and more stable over time. Despite K2-18b orbiting its star at a distance of only 18 cents, less than half the distance Mercury is from our sun, its surface isn't scorched. In fact, it might actually be just the right temperature for oceans. This close proximity has allowed scientists to get more data than usual, and what they've found is incredible. Using the James Webb Space Telescope, researchers have detected signs of water vapor in the atmosphere of K2-18b. Just let that sink in. We're talking about actual water, on a planet more than 700 trillion miles away. That single discovery instantly made K2-18b one of the most exciting objects in space science. But it didn't stop there. That water vapor was just the beginning. As scientists dug deeper into the light spectrum coming from K2-18b's atmosphere, something even more astonishing emerged. There were hints of a compound called dimethyl sulfide, or DMS. You might not have heard of it, but here's the thing. On Earth, DMS is almost always produced by living organisms, particularly by microorganisms that live in the ocean. There are no known non-biological processes that create large amounts of DMS naturally. So if we found it on K2-18b, it might mean life is present there too. Let that thought hang for a second. A distant world with water vapor. Temperatures that might be just right. And now, a molecule that, on Earth, is considered a potential signature of biological activity. Is this the moment we've all been waiting for? The first concrete sign that life might exist beyond Earth? If confirmed, this would be one of the most groundbreaking discoveries in human history. But before we jump to conclusions, let's understand more about what K2-18b might really be like. Scientists believe its atmosphere is dominated by hydrogen, which has some unusual effects. For one, it would make any oceans underneath warmer than Earth's, maybe even supporting exotic forms of life adapted to those unique conditions. And that's not all. Some researchers now think K2-18b might belong to a completely new class of planets, ones we're only just beginning to understand. Back in 2021, astrophysicist Niku Madhusudhan proposed a new planetary category, Hycean worlds, a term that combines hydrogen and ocean. These are planets with Earth-like cores but thick hydrogen atmospheres and massive, deep global oceans. The idea is revolutionary. Imagine a planet with 10 times Earth's mass and twice its radius, but instead of a crushing, unlivable surface, it holds warm, possibly life-friendly oceans under a hydrogen-rich sky. That's the kind of world K2-18b might be. And here's the twist. Hycean planets could have a much wider habitable zone than Earth-like planets. Their thick atmospheres trap heat more effectively, meaning liquid water could exist even farther from their host stars. That gives us a whole new set of targets to look for life, far beyond the narrow Goldilocks zones we've traditionally searched. Suddenly, the universe looks much more promising. Even more intriguing, these Hycean planets are easier to detect than small rocky ones like Earth. They're larger, they block more light during transits, and they emit stronger atmospheric signals. That makes them perfect candidates for telescopes like JWST, which depend on light to do their work. And that's exactly how the discovery around K2-18b happened. The James Webb Space Telescope used a clever technique known as transit spectroscopy to examine K2-18b. When the planet passes in front of its star from our point of view, some of the starlight filters through its atmosphere. The telescope captures this filtered light and breaks it down into individual wavelengths, kind of like splitting sunlight through a prism. Each molecule in the atmosphere absorbs specific wavelengths, leaving behind a unique signature or fingerprint that scientists can identify. By analyzing these fingerprints, scientists determined the atmospheric composition of K2-18b. That's how they found water vapor. That's how they detected methane and carbon dioxide. And that's how the mysterious hints of dimethyl sulfide first appeared. None of this would have been possible just a few years ago. That's the power of JWST. It's literally changing what we can know about the universe. So where does all of this leave us? We've gone from wondering if life might exist out there, to identifying real planets with real atmospheres that show possible signs of biology. K2-18b isn't just a dot on a chart, it's a potential second Earth. A world that might be teeming with life in forms we can barely imagine. And this might just be the beginning. The discoveries around K2-18b are opening the door to hundreds, maybe thousands of similar planets waiting to be explored. As we continue to push the limits of what our telescopes can see, we get closer to answering that ancient question. And maybe